Back to our booklet pages here. This is going to be page 45. And here we're working with Quadratic Applications. So here they're talking about traffic fatalities, blood alcohol. This is a true thing, 0.08. And they're wondering if you have this many accidents, what year would this apply to using this particular function here? Ends right there. So for letter A, we're putting this as our y value, and we want to determine what our x will be. So this corresponds, this formula, to drivers in the thousands. So when we look at this formula and we put this value in for A, we have to move the decimal place over from here to make this thousands. So now to put it in standard form, we're going to subtract this from both sides, and now we get over here for this value a negative 28.42, and all this part is the same. This is the same, this is the same, this is the same. So actually I have a calculator that I could just put the A value in, which is this, the B value in, which is this, and the C value in, which is this, and this then gives me X equals 7. So if this is the year 2000, this one is the year 2007. Now for the next one, we're just going to put this value here. And again, we have to change the place of the decimal. Move it from there to there. Now subtract this from both sides. And this time it becomes a negative 59.5. So our A term is the same. Our B term is the same, but our C term now is this. And again, if you have a calculator that can do that, that works out very well, because now our X equals 10. So this would, if 0 is 2000, our new X value is 10, so this will be 2010. And again, if you have to use the quadratic formula for this, it would be a pain, but if you don't have a way to solve quadratic equations on your calculator, this is what you'd have to do. Now, part of the protocol for doing these, of course, is to understand what they're asking you, and then they're giving you a function rule here, in a sense. And they're saying X corresponds to the year 2006. X equals 6, 2006. So how about 2009? What would that be? So for 2009, where we have our X value, we're going to substitute a 9 there. We're going to square that 9, get 81, multiply it by this, then 9 times this, which is negative, and then add this to it. You can actually put all of this into your calculator carefully, and you end up with 19.686, but this is trillion dollars. Now for part B here, in a sense, after what year after 2009 are you going to produce this many trillion in assets? So this is what your amount would have been here. And now we just have to solve this quadratic equation. Well, we're going to do so by transferring this, transposing it to this side. It becomes a negative that we will subtract from that, and then we'll have 0 equals 20.306. We identify our A value, our B value, and our C value, and interestingly it comes out to be X equals 11. So again, we're talking years, starting in 2006 is 6, so 2009 is 9, so 11 would be 2011. Now as you read example 3, here's our formula that I've written this way. We're going to take something, throw it off a tall building, and we're going to see how long it takes to reach the ground. And this is the function of it. So we get 16t squared equals the height of the building here, which is 1936, my birth year. We're going to divide both sides by 16. We get t squared equals 121. And from an earlier lesson, we know we can take the square root of this and get t. And the square root of this, we don't need a plus and minus here because we're going to have positive time. And we get 11 seconds. So that was an easy one. Now for this one, as we read it, so we're going to throw something, and as we throw it up, eventually it's going to reach a pinnacle and then come back down. So as it goes up, it's going to reach 34 feet here, and as it comes down, it's going to reach 34 feet there. Again, we started at 0, and this will be 0. But they want to know at what times will it be 34 feet from the ground. So we're going to put where our h is here, 34 equals a negative 16t squared plus, now here they're saying we're thrusting it with our initial velocity of 49 feet per second, so we're substituting our v sub o here with this, our initial velocity, and we're going to start at the ground here where this is actually 0. So I like to keep my values positive, so I'm going to move everything over to the other side now. So I get 16t squared positive on this side minus 49t, and this is still on that side, plus 34 equals 0. Now I can put that into the quadratic formula, or into my calculator, is what I did. And my A term now is 16. My B term is a negative 49. And my C term is a positive 34. And I get then T equals 1.0625, or T equals 2. So as it's going up, this is our first T value, time, and then it's very quick, it's going to come down, and then this is our second T value, and this is how I set it up and got my answers. Now this is page 46, and we're looking at the Pythagorean theorem, where we're asked to solve this. So let's read it carefully and set it up. Now this is meant to be a study aid, so let's see if we can understand what's going on here. So we have a 13-foot ladder that's leaning against a wall, and it's 5 feet away from the wall. So in a sense, this is our A side, our B side, and our C side, the hypotenuse. So the first thing we have to find is, what is our B value? So we say A squared, which is 5 squared, plus B squared equals C squared. So this is going to be 25 plus B squared equals 169. We're going to subtract 25 from both sides, and we get B squared equals 144. Take the square root of both sides, and again I'm only looking for positive values. My B is 12. So this side is 12. Now they're saying what we're going to do, so this original distance here was 12. I'm going to move the bottom out by 1 foot. So this was 5. I'm going to move it out by 1 foot, so the bottom side A now is 6. My hypotenuse is still 13. But we're asked how far down the wall from the original 12 feet does the ladder drop? Okay, so again, same formula. A squared plus B squared equals C squared. Now A squared is now 6 squared, which is 36, plus B squared equals still 169, which is 13 squared. So now I'm going to subtract 36 from both sides, and I get 133. Now I take the square root of that, and again I'm only interested in the positive value. I get B equals, well, it's approximate here. When I take the square root of that, I get 11.53 feet. Now I subtract that from the original 12, and I now get, it's going to drop down there about 0.47 feet. Now I see the key gives 0.48. I'm not quite sure where they got it from. Maybe I didn't round off exactly, but that's basically how this is done. Now we're going to spend some time on this, but to do these properly, and this is page 47, it's going to go from 47 on. We're going to stop here after I give you a short introduction. But in order to do these, we have to introduce, as a review, a standard form of the quadratic expression. ax squared plus bx plus c. Now, if we fiddle with this, we can convert this formula into something that is equal, and it looks like this. Parenthesis, well, a parenthesis x minus h, the quantity squared, plus k. Now in this form, we can pick out, and I often call this one the vertex formula form. We can pick out the vertex. The vertex of any parabola using this form is the opposite sign of h, which here it looks like a negative, so that will be a positive, plus k. Now, since this is an ordered pair, it's not a plus, it's a comma. So this is our x value, and this is our y value. Now, there's some other words that we're going to be using here too, and I'm going to give you some background, which we do in the textbook lesson as well. And that is, when we have a parabola, which is in this form, if our a value here is positive, this a value is positive, the parabola opens up to the top. And the bottom of the parabola here, this point right there, is called the vertex, written in the form x comma y, which have the values h comma k. And the k value, in this case, since it's opening upwards, is called the minimum. And the x value makes up what is called the axis of symmetry, which goes right through that vertex point. So, as background then, this is where we'll stop, because we want to keep these under 20 minutes. But when we start this on the other side, we'll be using all of this information. And I just want to do one other thing too, as we find that our a value here or here, if that a value is negative something, then our parabola is going to open up downwards, and our vertex would be on top, and that would be considered the maximum. And x is still our axis of symmetry. It would be our y value, is how high up it's going to go. If it's the maximum. If it's the minimum, it's how low will it go. That would be your y value.